Firstly, I will be discussing about what are all the things that I learned during this internship period, like C programming, embedded C, C++ programming, project requirements, and the peripherals that are needed for the project. Secondly, I am going to show a demo video in relation to the project. In the first week of my internship program, I have learned some of the important concepts related to the programming part, like what is C, why it is needed to support the embedded system, and what are all the differences between C and C++ programming. So C is a procedure-oriented programming language, whereas C++ is an object-oriented language which supports constructors, destructors, classes, objects, etc. Here, we will see about the embedded C program. Embedded C is an extension for the C program. It executes a similar task continuously, so there is no requirement for changing hardware like additional memory. Here I am used the embedded C program for programming the Arduino Uno. Embedded system is nothing but a combination of hardware and software that will perform a certain task. It is like programming the physical objects. Some of the real-time aspects of embedded system are hard real-time, firm real-time, and soft real-time. Hard real-time means it should meet its deadline, life-critical application. Firm real-time, it is similar to hard real-time property. Soft real-time, it have tolerance in meeting its deadline. I have used Arduino Uno to implement my project. Arduino Uno is a development board for the microcontroller Atmega 328P, which is an 8-bit microcontroller. Arduino Uno has 6 analog pins. There are some pulse width modulation supporting pins among the digital pins. The Arduino Uno has an inbuilt ADC of which its resolution is 10-bit. Generally, an ADC is used because microcontroller can understand anything in digital form only. Now, let's move on to the project's requirement. Our aim is to control the garden lights based on the availability of sunlight. That is, during the daytime, the sunlight will be more. So we need to turn off the garden lights. During sunset, it is getting darker. And now, we need to turn on the garden lights. To sense the available sunlight, we are going to use the LDR sensor. The data from the LDR sensor is sent to the Arduino, which then sends the required control signal to control the garden lights. Our second requirement is to control the temperature system of our home. The temperature control system consists of a heating resistor, a temperature sensor, and a cooler, which resembles temperature control system at our home. The process is to read the temperature continuously from the temperature sensor and display it on the CLCD. I will be using the heater and the cooler for controlling the temperature. The temperature sensor is used as an input to send the temperature details of our home to the Arduino. Then, based upon that value, we are going to use the heater and cooler accordingly. We have to create cooler pin, heater pin, temperature sensor widgets on the Blink IoT app for the controlling of temperature using the app. If the button widget is at logic high, cooler will be turned on, and if the button widget is at logic low, cooler will be turned off. Similarly for heater, if the button widget is at logic high, heater will be turned on, and if the button widget is at logic low, heater will be turned off. And lastly, we have to control the volume of water in the water tank by turning on and off the inlet and outlet valves of the water tank, reading the values of the water level through serial communication and displaying it on the CLCD. Firstly, we are going to read the volume of water in the water tank. This can be done by sending the commands through serial communication and fetching the data of the water and displaying it on the CLCD. After obtaining the data from the serial tank, then we have to control the inlet valve. So if the button widget is at logic high, turn on the inlet valve by sending commands through serial communication. If the button widget is at logic low, turn off the inlet valve by sending commands through serial communication. For outlet valve control, if the button widget is at logic high, turn on the outlet valve, or else if the button widget is at logic low, turn off the outlet valve. Now, let us see about the details of the peripherals that I used to make my project. A 16x2 LCD display where it have the ability to display any characters or numerical values for 16 columns and 2 rows. The rows represent the number of lines and the columns represent the number of characters. And a PCF8574 input-output expander and a bar of 8 independent colored LEDs as output. Next, I will be using Ethernet chip W5500, which can support up to 8 sockets. Since it is required to make a connection between the cloud and the Arduino board, we use the Ethernet chip and LDR sensor. LDR sensor is the light dependent resistor connected in series with 10K resistor, which is used to control light's resistance. Here we will be seeing about the temperature system. The temperature control system consists of a heating resistor, an LM35 temperature sensor, a cooler and an infrared tachometer, and a serial remote tank. It is integrated in my project in which it resembles the actual tank in our home. Now let us see about the IoT based home automation solution. After interfacing all the peripherals to the Arduino UNO, we will be able to perform all the actions as mentioned in the project requirements. So we can be able to control the brightness of the garden lights using LDR sensor and the temperature system of our home and the volume of the water in the water tank by using Blink IoT app. Blink application. By this mobile application only, I am going to implement the IoT based home automation system. I have configured the Blink application. For that, we need to perform some step-by-step process priorly. We need to create virtual pins for the data stream process. Here, I have created 7 virtual pins. Virtual pin 0 as a switch for cooler, virtual pin 1 for temperature gauge, virtual pin 2 for heater, virtual pin 3 for water volume gauge, virtual pins 4 and 5 for inlet and outlet valves respectively. Now the Blink is ready to control our project from any part of the world. Moving on to the tools or softwares used here, as this was an online internship, it will be difficult to go with hardware implementation. So this project is done only by PixSimLab for simulation, and the peripherals are integrated using Arduino using PixSimLab software. I have used a null emulator for serial UART port communication between the Arduino UNO and the serial tank. Arduino IDE is used to compile our code and convert into .x files. After that, we will be able to upload those files to PixSimLab for simulation. Next, I move on to the project integration. Now you can see that all the peripherals are integrated together to meet our project requirement. All the peripherals used were interfaced with Arduino UNO and it forms an embedded system. Internet of Things comes into action when we try to control it using the internet through Blink IoT app. Now let us see which is interfaced to which and how the interfacing is done between peripherals, Arduino UNO and the Blink IoT app. As we know that all the virtual pins are responsible for an action, I will be using the heater and the cooler button widgets for controlling the heater and the cooler, and the gauge shows us the temperature reading. Here I have used the I2C communication protocol to interface the CLCD with the Arduino UNO. I will be displaying all the values of temperature readings and the volume of water in the CLCD. Configuration of serial tank is done using UART serial communication, which is Universal Asynchronous Receiver Transmitter to the Arduino UNO. So now we will be able to control the heater, cooler and the serial tank using Blink IoT app, and the garden lights will perform the actions according to the amount of light that has been received. Now we are going to see our project demo video. Our first requirement is to control the brightness of garden lights. The brightness of LED varies according to the value of LDR sensor, which resembles controlling of garden lights based on the availability of sunlight. Here we can see that the brightness of LED decreases when more light falls on the LDR sensor, and the brightness of the LED increases when less light falls on the LDR sensor. Now, our second requirement is to control the temperature system of our home. So, when the heater is turned on, the temperature starts increasing and the value is displayed on the CLCD and in the Blink IoT app. When it reaches the threshold value of 35 degrees Celsius, the heater turns off automatically and sends notification to the Blink IoT app. When the cooler turns on, the temperature falls rapidly and back to its normal room temperature value. This is our second requirement. It consists of heating resistor, an LM35 temperature sensor and a cooler. The temperature is displayed on the gauge widgets and the CLCD. Here, our last requirement is the serial remote tank control. When we connect our serial tank to the PixSim lab, then the volume of the water in the serial tank starts increasing automatically. Here, the serial tank resembles the actual water tank in our home. When the volume of the water reaches 3000 liters, the inlet valve turns off automatically and sends notification to the Blink IoT app. When we turn on the outlet valve, then the volume of the water starts decreasing. As soon as it reaches below 2000 liters, the inlet valve turns on and sends notification to the Blink IoT app. If we turn off the outlet valve, then the volume starts increasing again. So, as a result of this internship, we simulated the complete home automation solution using PixSim Lab, and I have learned the technologies like Arduino UNO, PixSim Lab and the Blink IoT application. I am now able to control my project using widgets in the Blink app and able to see the notification in the Blink app and CLCD, and also reading in the gauge widgets. Once again, I would like to thank emertxe Information Technologies for this opportunity, which gives me a knowledge on embedded system and IoT.